Hi students, welcome to Max Point of View. Today we are going to understand the concept of current electricity part B, that is nothing but EMF. EMF is nothing but electromotive force, terminal voltage and voltage drop. See, after learning all these things, we are going to learn the factors affecting EMF. EMF is nothing but electromotive force, then factors affecting internal resistance and combination of resistance, in that resistance in series and resistance in parallel. If we learn all these things, then current electricity part B is we have understood completely. After that we are going to solve each and every theory question and each and every numerical. Those two videos also be available in the description box. So without wasting any time, we'll start with our definitions of EMF, terminal voltage and voltage drop. See, in this chapter, current electricity part B, it is very important to understand the difference between all the three, because based on these three only we are going to solve many number of numericals. In this chapter, that means in part B, we have around 31 numericals. All the 31 numericals are completely different from one another and everything is very important. So only in this part the numericals will be little average, advanced level questions, but if you understand the concept properly, when to go for terminal voltage, how to find terminal voltage, how to find voltage drop and what is EMF, all those things, then it will be very easy. Okay, now we'll start with our first definition, EMF. See, always learn the definition for the sake of writing it in the exam. After that, after learning the definition, understand the inner meaning of it, then it will be easy for us to solve all the theory question as well as numericals. Okay, listen. EMF, as I told you, electromotive force. How can we define it? When the circuit is open, when the circuit is open, no current will be drawn from the cell. Is it correct? Listen, when the circuit is open, I'll draw the circuit. Listen, assume there is a bulb. Okay, assume there is a bulb. Now, when the circuit is open, current will not flow. That is what I have written here. When the circuit is open, no current will be drawn from the cell. Next, then the potential difference, okay, produced by the chemical reaction between the terminals of the cell. See how you can write the definition of EMF. When the circuit is open, no current will be drawn from the cell. Then the potential difference is nothing but the voltage. See, all the three, EMF, terminal voltage and voltage drop, all the three represents voltage only, but in different ways. Okay, EMF, how can we define it? When the circuit is open, no current will be drawn from the cell and the potential difference produced by the chemical reaction between the terminals of the cell. This is the definition of EMF. Actually, in very simple way, if you want to understand it, the voltage in the battery is called EMF. Whatever the voltage they'll give, okay, this is the cell, correct? If you add one more cell, it becomes a battery, correct? So the voltage in the battery, assume 5 volts, the voltage in the battery is nothing but EMF. This is how you need to understand, then it will be easy to solve any theory question or a numerical. Next we will go for the terminal voltage. Listen, okay, when the circuit is closed, when the when this circuit is closed, when the circuit is closed, the current will be drawn from the cell and the potential difference between the terminals. Terminals is nothing but these electrodes, positive and negative electrode, plus and minus. The potential difference between the terminals is called terminal voltage. So as we understood EMF is nothing but the voltage in the battery. Then what do you mean by terminal voltage? Listen, when this voltage is there, so when the current flows here, when the circuit is closed, when the current flows, there will be a voltage drop. Because of the resistance in any appliances or anything. So we know there will be a resistance in all the metals and all the wires which we are using, correct? There will be some voltage loss. After losing some voltage, how much voltage is remaining? That is nothing but terminal voltage. See how to understand in a proper way. When this voltage, okay, from the battery is nothing but the EMF. When the circuit is closed, the current will be flowing. We know whenever we are using conductors, we are not using superconductors, right? We are using the normal conductor, so normal wires, and this bulb will also have some resistance. Because of these resistance, some voltage will be lost. Okay, after losing that voltage, how much voltage is left? That left voltage is called terminal voltage. The voltage between these terminals, positive and negative. See, between these two, whatever the voltage is there, that is EMF. Okay, so from here, from this point to this point, whatever the voltage is there, okay, whatever the voltage is left after losing the voltage, the left voltage will be terminal voltage. Then how much voltage is lost? That is nothing but voltage drop. Okay, this lost voltage will be in the form of heat energy. Okay, in the form of heat energy. So how can we define voltage drop? The difference in EMF and terminal voltage. That's it. And how we can represent it in the numericals, it is very much important. EMF, we can write it is EMF aram se, but terminal voltage we will use capital V. Okay, small voltage we used to represent voltage drop. Okay, now we'll understand all these three, because why I am stressing all these things, because we are going to use it in numericals, theory questions and definitions also. If you, instead of using the definition we write it to get the marks, but understanding the concept is very much important for the logical type of questions. EMF is nothing but the voltage in the battery. When the circuit is closed, the current flows, and because of the resistance in the conductors and the bulb, there will be a loss of voltage in the form of this one, heat. So the last voltage will be voltage drop. After losing that voltage, how much voltage is left? Okay, that is nothing but terminal voltage. So terminal voltage we represent it as capital V, voltage drop we represent it as small v, and the difference between the EMF and terminal voltage will be voltage drop. And one thing you need to know, EMF will be always greater than the terminal voltage. Is it correct? Because the voltage drop, the voltage we are getting from the battery will be always greater than the terminal voltage. Keep this in mind. Now we'll understand what are the factors which will affect EMF of the cell. So the first factor will be the material of electrode. Okay, materials of the electrode. What material? See, what do you mean by electrode? Electrode we know, assume this is the, in electrolysis process, okay, in electrolysis process we use metals, correct? So it will be immersed in electrolyte, correct? So in electrolysis process, whatever we are learning from this part B, it will be, everything will be happening inside a cell. Everything will be happening inside a cell, small cell. That is what we are learning from part B. That you need to understand. In a small cell there will be electrolyte, and electrolyte means the liquid. Electrodes, electrode means the metals, okay, what metals. So what metal we are using, EMF will also depends upon what metal or material we are using as electrode, okay. This is the first factor. Then the electrolyte, what electrolyte we are using. So electrolyte is nothing but the liquid. See, in the board exam they cannot ask how the material and electrolyte will affect EMF, because we don't know what kind of material and what kind of electrolyte we are going to use. There is no specific material and electrolyte, correct? So how these two are affecting EMF, this question will not be asked in the board exam. The only question they can ask is what are the factors affecting EMF. That will be materials of the electrode and the electrolyte. And there will be some confusion between the students, right? They will write a few other this one factors also, but what are the, and we need to know what are the factors which will not affect EMF, okay, not affect EMF. If you know these two, see, the only thing you need to know is what are the factors. These are the only two factors which will affect EMF. Then what are the factors will not affect EMF? The first one will be shape or size of the electrode. See, if it is big, okay, and the different size and different shape, this will never affect EMF. Then the distance between the electrodes, okay, if the distance is far or near, it will never affect EMF. And the amount of electrolyte, okay, if we use more amount of electrolyte, more amount of liquid or less amount of liquid, it will never affect EMF. So these are the two factors which will affect EMF. How these are affecting EMF will not be as in the board exam, don't worry about it. And these are the factors which will never affect EMF. So these things you should not write in the exam. So only two factors you need to remember. That's it about the factors affecting EMF. As we have understood EMF and terminal voltage. See, for terminal voltage now onwards I am going to use the symbol, because you need to understand the symbols for the numericals also. That's why it is very much important, the difference between EMF and terminal voltage. Listen, always when it comes to differences, go for the definition first. Okay, definition of both EMF and terminal voltage, that is what we have learnt earlier. Next, see, EMF does not depends on the amount of current drawn. See, I am using the symbols, right? But in the exams you should never use symbols. Definitely you will lose marks. So you have to write it in the expanded form. I means current. Why I am using the symbols? Why? Because I want you to understand the symbols. Okay, because we are going to use all these symbols in the numericals and some theory questions. You need to understand the meaning of the symbols. That's why. But never use symbols while writing it in the form of sentence. Next. See, this will depends exactly opposite to this one. Okay, EMF will not depends upon the amount of current drawn. This will be exactly opposite. Depends. It depends. So how can you write this statement in a different way? It is independent of current drawn from the cell. That depends upon the current drawn from the cell. And EMF, okay, will be always greater than the terminal voltage only if the circuit is closed. Keep this in mind. See, whenever we are learning the definition of EMF and terminal voltage and voltage drop, I told you EMF will be always greater than the terminal voltage. That is correct, but only when the circuit is closed. When the circuit is open, okay, see here the same thing. So when the circuit is closed, voltage drop will be less than the EMF. That is what you are going to write it here. Okay, the same thing in a different way. That's it. Then EMF will be equal to terminal voltage only if the circuit is open. Keep this in mind. Now we will understand the concept of internal resistance. See, this is also very simple. Listen, internal resistance will be represented as small r. Okay, capital R is the resistance, external resistance. Internal resistance will be represented as small r. So it is very simple. The resistance offered by the electrolyte in the cell. So we got to know in the inside a cell, inside a normal cell which we use it every day, inside that there will be a liquid that is nothing but the electrolyte. So the resistance offered, the resistance produced or resistance offered by the electrolyte in a cell, okay, is called internal resistance. Okay, assume this is the battery or a cell. See, the difference between battery and a cell is if I use more than one cell, that becomes a battery. Okay, so this will be plus, this will be minus. The resistance of, see, assume this is 5 volts. Okay, this will be EMF. Then if someone has given 0.2 ohm, 0.2 ohm, that means this is the resistance offered by the cell, the resistance offered by the cell or resistance offered by the electrolyte in the cell. So this will be considered as the internal resistance. See, these are the external resistance we are using, correct? This is capital R and this will be small r. For the, whenever we use it in numericals, we always assume this will be in series with the cell. This will be in series with the cell. And I know you don't know what is series connection and parallel connection. Don't worry, after learning this one, that is our next aim, correct? That is what we are going to learn. What is series connection, what is parallel connection, how to solve all those things. That is very much important. If you have learnt it only, then only we are going to solve all the numericals properly. If that is not learnt, then it will be very difficult, because in the board exam, one definite resistance in parallel and resistance in series connection questions will be there, that too for 3 to 4 marks. So keep this in mind. Numericals from this chapter is very, very important. Okay, now the resistance offered by the electrolyte in the cell is called the internal resistance, that will be represented as small r. What is the difference between these two? This is an external connect, we connect it in the circuit. This will be from the cell. So that is the difference between internal resistance and external resistance. So now we have learned EMF, correct? EMF, terminal voltage, voltage drop, correct? So now we will understand the expressions, the formulas, how to use it in the numerical. Listen, we know EMF, okay, is the voltage offered by the this one battery or a cell. Next, terminal voltage is nothing but the voltage left in the cell after losing some voltage. So if we add these two, okay, the last voltage, that is nothing but voltage drop, and that will be represented as small v, and the left voltage, that is nothing but the voltage left in the cell, okay, voltage left in the circuit, that is nothing but the terminal voltage. So how we can find the value of terminal voltage? IR, okay, current into the external resistance. How we can find the value of voltage drop? That is nothing but current into internal resistance. Okay, because of the internal resistance there will be loss in voltage, and that loss in voltage will be nothing but the voltage drop. So I, we can take it as common, R plus R. This is one of the formula we are going to use it in numericals. There are many formulas. Before starting the numericals, first we will discuss the new formulas which we are going to use to solve all the numericals. Then we go for the numericals. Don't worry about it. This is the basic formula for this all terms which we have learnt. Now we will learn the factors affecting internal resistance. So factors affecting internal resistance. See, again I am using symbol, but in the exam you should never use symbols. You have to use it in the expanded form. Internal resistance you have to write. Okay, the factors. First one, the surface area of the electrode. Okay, so we know if this is the representation of cell. Okay, see, these are the electrodes and this is the electrolyte, that is nothing but the liquid, correct? So surface area of the electrode, that means the surface area of these electrodes, okay, the metals or the conductors. Okay, if the surface area is more, see, surface area is inversely proportional to resistance. That means if the surface area is more, internal resistance will be less. You understood? See, if the surface area is more, internal resistance will be less. This is nothing but they are inversely proportional. See, if they in the exam you need to understand, if they are asking just to state the factor, this is what you are going to write: surface area of the electrode. That's it. State the factors. How surface area of the electrode is affecting internal resistance means these two are inversely proportional, you can write, or you can write, sir, if the surface area is more, internal resistance will be less, or else you can write it in different way. If the surface area is less, internal resistance will be more. See, inversely proportional, more the surface area, less the internal resistance, less the surface area, more the internal resistance. There are three different sentences, right? You can write any one sentence for how the surface area of the electrode will affect internal resistance. See, sometimes whenever you are learning something, there might be a chance to get confused, correct? So whenever you get confused, go back and watch it properly one more time. Definitely you will understand. Then the next point will be the distance. Okay, the distance between the electrodes. Okay, distance between the electrodes is directly proportional to R. See, the factor affecting the electrode is the distance between the electrode. How it is affecting R, they may ask you in different way. What is the relation between the distance between the electrodes and the internal resistance? That means you have to write these two are directly proportional. That means if the distance between the electrodes, is more, okay, more or larger, the internal resistance will be greater. That's it. If the distance between the electrodes is more, then the internal resistance will also be more. So this one also you can write, or this one also you can write. Then concentration of electrolyte. See, concentration of the electrolyte. You know what you mean by concentration, right? Concentration and dilution, correct? That is what we have learnt in chemistry. Concentration, okay, if the concentration of electrolyte is more, okay, concentration is directly proportional to internal resistance. That means if the concentration of the electrolyte is more, okay, then the internal resistance will also be more. The last factor will be temperature. See, this is one of the confusing factors. Why? Because when it comes to the normal resistance, external resistance, capital R, if the temperature is more, external resistance will be more. But when it comes to small r, internal resistance, temperature, okay, is inversely proportional to internal resistance. That means if the temperature is more, internal resistance will be less. So this one you should remember. Okay, temperature is directly proportional to capital R, that is external resistance. If the temperature is more, external resistance will be more. But when it comes to internal resistance, if the temperature is more, the internal resistance will be less. See, if the temperature is more, internal resistance will be less. We are going to learn how to identify whether the given resistance are in series or they are in parallel. So first we'll learn about series. After this one we'll go for parallel. Okay, listen. Whenever we need to identify whether they are in series or parallel, we need to identify how many wires are connected between them. What do you mean by that? Listen, whenever there is a resistors, okay, how we can connect them? Using a wire, correct? One wire will be coming from this resistor and one wire will coming from this resistors. Okay, so whenever these two are joined, how many wires are connected? Totally 2. Okay, now one wire will be coming from this resistor and one wire will be coming from this resistor. How many wires are joined? 2. If the number of wires joined are 2, then it is in series. More than 2, it is always parallel. More than 2 means anything. It may be 3, 4, 5, anything. Okay, if the number of wires joined by 2 resistors are only 2, then they are in series. Okay, less than 2 it is not possible. Less than 2 means they are not even connected only. This example is same as this one. See, from this resistor one wire is coming and this resistor one wire is coming, correct? These two are connected somewhere here, somewhere here. So how many wires are there? 2 wires, so they are in series. Now so we'll talk about this one. See where these two are connected, somewhere here. For this point, how many wires are coming? One wire from this resistor and one wire from this resistor. So totally how many wires? 2 wires. This is in series. Next, we'll talk about these two. These two are connected here. One wire is coming from this resistor, one wire is coming from this resistor. So this is in series. We'll talk about these two. From one wire, from this resistance, one wire is coming. From this resistor, one wire is coming. So totally 2. Again here also 2. Here also 2. So all of them are in series. All of them are in series. Say in exam, definitely you will get both series and parallel. Don't worry about it. First we will identify whether they are in series or parallel. I will help you to solve all those combinations. Now listen. Now see this diagram and this diagram. This is a square and this is a rhombus. See, if you tilt it like this, the same diagram, it is here. See, at this point, these two resistors are connected. One wire is coming from this resistor and one wire is coming from this resistor. So only two wires. At this point, same two wires and 2 wires. Once we identify whether these are in series, then it is easy to solve. See, solving series connection, it is very easy. Just adding the values. I'll give you some examples. Listen. Assume this is 2 ohm and this is 3 ohm. This is the formula for resistance in series. S represents series. Listen, and we need to understand why we need to do all these things. Okay, why we need to do all these things? Whether why do you need to identify whether they are in series or parallel? Listen, assume these kind of resistors are in a circuit. Instead of using so many resistors, we will use only one resistance, that is the final value. Okay, after solving all these things, we will get one value, correct? One resistance value. That resistance we are going to use it in circuit instead of using so many resistance. Okay, while solving the question, you will understand. Okay, listen. These two are in series, correct? Series formula is adding all the resistance. How many resistance we have in this case? 2 resistance. Just add them. So 2 plus 3, that is 5 ohm. See, once we add it, you know what happens? Once we add it, these two resistance will become one resistance. Okay, once we add it, okay, these two resistance will become one resistance. Next, See, this connection is exactly like this one only. If I extend like this, see, if I move this resistance like this connection is same as this one only. So assume this is 4 ohm and this is 3 ohm. So total RS will be 7 ohm. Okay, so using these two, after solving these two, we'll get only one resistance. Okay, next, assume this is 1, 2, 3, 4. We know all of them are in series. 1 plus 2, 3, 3 plus 3, 6, 6 plus 4, 10. Okay, so after solving all these things, how many resistance we got? We get only one resistance. See, after solving all these things, I'll get one resistance. That value will be 10 ohm. How to use this resistance? While solving the problems, you will understand. Okay, first we are identifying whether they are in series. Once we identify, how to solve these kind of things. Again, 2, 2, 2, 2. Assume all the values of resistance is 2. Then answer will be 8 ohm. Okay, and 8 ohm will be the value of only one resistance after solving all these things. So this is how you identify series connection and solve them. Now we learn how to identify whether the resistance are in parallel or not. Okay, so when it comes to, if you have understood series connection, then the parallel connection is also easy. Only the formula is different. Listen, first we'll identify, then we'll go for the formula. Listen, these two resistors are connected here and here, correct? Here and here. But in series connection, we learned whenever they have connected somewhere, we have to see how many number of wires are connected. See, what at this point these two are connected, correct? One wire is coming from this resistor, one wire is coming from this resistor. See, there is one more extended line, right? This one more extended line is coming. See, this is also you have to include as a wire only. One wire is coming here, one wire is coming from this resistor, one wire is coming from this resistor. So totally how many resistors are connected? How many wires are there? 3 wires. Then definitely this is in parallel. So at the junction point, at the connected point, you have to see how many wires are there. See, at this point also, at this point, one wire is coming from this resistor, one wire is coming from, will identify as R1, R2. One wire is coming from R1, one wire is coming from R2, and one more wire is coming extended wire, right? So totally there are 3 wires. So this is in parallel. Now at this point, assume this is R1, R2 and R3. See, at this point, see, if the diagram is like this or like this, both are same. Both are same. Listen. Now at this point, how many wires are connected? One wire is from R1, one wire is from R2, one wire is from R3. So there are 3 wires and one more extended wire, correct? One more extended wire. So totally 4 wires are there at this junction point. Definitely this is in parallel. More than 2, it is always parallel. Equal to 2, it is series. Less than 2, it is not possible. Okay, next, at this point, see, these two resistors R2 and R3 are connected here, correct? R2 and R3 are connected here. How many wires are there? One wire is coming from R2, one wire is coming from R3, and one more wire is coming from, see, at this point. Okay, this wire is also coming here only, and one more extended wire, this is also coming here only. So totally 4 wires are there. Definitely this is in parallel. Now we'll talk about this one. Next, listen, these two, we'll see about these two. How many wires are there? One wire is coming from R1, R2, R3, R4, R5. Okay, one wire is coming from R1 and one more wire is coming from R2. So how many wires are there? Only 2. This is definitely in series. This is definitely in series. Now we'll see here at this point. Okay, one wire is coming from R1, one wire is coming from R4, one wire is coming from R3. So totally 3. These 3 are connected in parallel. At this point, these 2 are connected in series. At this point, 3 wires are coming. 1, 2, 3. So this is in parallel. Okay, first we are just identifying it. I'll teach you how to solve them. Listen. Now we'll talk about this point. Okay. How many wires are connected at this point? One wire is coming from this resistor R1, R2, R3, R4, R5, R6, just naming instead of giving values. R1, from R1 one wire, from R2 one wire, from R3 this wire is also connected here only. I know this wire is connected here, but these two are joined and coming here, correct? These two are joined and coming here. So totally how many wires? 1, 2, 3. So totally 3 wires are connected. Definitely they are in parallel. Listen, you will be thinking we are talking about only R1 and R2, why we have to include this one? See, if you think like that, in the world there will be no parallel connection only. Okay, see, whenever we are talking about R1 and R2, we know we are talking about only R1 and R2, but how many wires are connected between them? One wire from this one wire from this one, and one more wire from this one. And see, at this point, one wire from R1, one wire from R6, one wire from R5. So totally 3 wires parallel. At this point also, one wire from R6, R5 and R4. So parallel. At this point also, one wire from R4, one wire from R2, and R2 and R3 are connected and coming together. So totally 3 wires. So they are in parallel connection. So if you identify which is series and which is parallel, then aramse we can go for the formula. See, in series connection, you know, okay, just applying the formula, adding them, that's it. But when it comes to parallel, RP is equal to 1 by R1 plus 1 by R2, 1 by R3, it keeps on going. Okay, whenever, listen, whatever the values, I'll give you one example, I'll show one example. Listen, assume we'll talk about this question. Okay, 2, 3, 4, 2, 3, 4. 1 by RP is equal to 1 by 2. See, we have to take the reciprocal of these values. 1 by 3 plus 1 by 4. What is the LCM? That is 12. So this will be 6, this will be 4, and this will be 3. Answer will be 13 by 12. Correct? This is the final answer. Correct? No, completely wrong. Why? Because we are not finding RP, resistance in parallel. We are finding 1 by RP. So to find RP, we have to take the value of this final reciprocal. We have to take at this final step. That will be 12 by 13. 12 by 13. See, to find the resistance in parallel, few students will forget to take reciprocal at the end. So for them we have one more formula. Listen, but this formula, you know, there is a problem. This formula is limited to two different, okay, if they are connected only two resistance in parallel, when they are going to use this formula. Listen, RP is equal to R1 R2 by R1 plus R2. Here, if these two, only two resistors are there, we are going to use this formula. If three resistors are there, we are going to use this formula. R1 R2 R2 R3 plus R1 R3. This one. See, you can go for the textbook formula. This is the textbook formula, okay, but you should not forget to take reciprocal. Sometimes these formulas will be easy, but sometimes the textbook formula will be easy. So whichever is easy for you, you can go for it. This formula is only applicable when only there are two resistors are in parallel. This formula is only applicable only when three resistors are in parallel. More than three, we have to definitely go for the textbook formula only. So it keeps on going. Okay, we have to take the LCM, and normally we have to calculate, but at the end we have to take the reciprocal. Till now we have understood how to identify whether they are in series or parallel. Now we have to learn how to solve them. Then only we will understand completely. That we have solved from ICSE grade 10 physics textbook. Correct? That is from electricity part B, from the question number 6 to question number 19. That video poster will be coming at the end of this video, and it is also available in the description box. Question number 6C, we have solved so many questions in that video. From question number 6 to question number 19, you are going to learn how to solve resistance in series and resistance in parallel. Thank you.